Hi, it's Keith Innovates here, and now video 3 in a series on RFID, blockchain and supply chain. So in this one I want to dig down further into identity within a supply chain. For a supply chain to work, one of the things you need is good identity and authorization management, which in simple terms is being able to determine who's involved, are they allowed to do what they want to do, and are the goods that are being passed through the system actually what they say they are. Authorization, for example, as I mentioned before, is something like a driving license, which has two handy properties. One is it identifies you, and secondly, it gives you the authority to drive a vehicle. So identity is really key in authorization. You can have a situation where you don't have to specifically identify a person in order to authorize them. For example, being able to prove that you're an employee at a company is enough to allow you onto the company premises or into the office. It's not necessary to know the particular person. However, in general, we tend to tie the two together, even in allowing people into the office, because it's also handy to know when they arrived and when they left. When it comes to determining identity, this is called authentication. You want to authenticate that somebody is really who they say they are. And in the computer world, there are two fundamental kinds of authentication. There's mutual authentication and there's one-way authentication. So I'll describe mutual authentication first, and the best analogy I have for that is when a spy meets their handler in order to hand over the secret plans. They perform mutual authentication, if you watch spy movies, by sitting down on a bench at an agreed place and time, and then the spy says something like, the crocuses in Gorky Park are wonderful at this time of year, and the handler says, yes, but I prefer the daffodils in Helsinki. And as a result, because they previously agreed that these were the code sentences, they now know that they're talking to the right person, and the spy is not accidentally going to hand the briefcase over to some random stranger. So that's mutual authentication, where there's a shared secret, and there are all sorts of clever techniques to make sure that in the computer world, that when the secret is exchanged, it's done in a way so that people can't listen in and sneakily get hold of that secret. Now, mutual authentication is great if, for example, you have a system like the London Underground with Oyster cards, where your card needs to be topped up with extra credit in order to be able to travel, and you have to go to a designated charging point, because it's possible to load all the Oyster cards with the same secret that the credit points have. And then you put your card in the machine, and the machine and the card authenticate mutually, and then the card allows the credit point to add more credits. So all fine and good, but the problem you have in supply chain is that all the parties involved don't necessarily trust each other. So those of you interested in blockchain will already see light bulbs lighting up above your heads. In a supply chain, the goods pass through various hands, and some of the parties are more trusted than others. And certainly in a global supply chain, one where goods are moving between companies and through different freight companies, it's not really feasible to have a shared secret that is shared amongst all the parties. You may change your supplier, or someone in the supply chain may find a better transport company at a moment's notice. So to put in place an infrastructure where you can sort of randomly sign up and then exclude various parties is very, very difficult if you're going to do it with mutual authentication. And this is where one-way authentication starts to prove itself. One-way authentication is authentication where you prove to the world that you are who you are without requiring anything in return. And in the computing world, this is commonly done through digital certificates. For example, every HTTPS website out there has a digital certificate that proves that it is the website it says it is, and these are used to prevent people from impersonating other websites. One-way authentication is done through asymmetric key cryptography normally, which allows for digital signing. And that is the analogy of one-way authentication. I can authenticate myself to anybody with my signature. Of course, physical signatures are relatively easy to forge, although experts can go and look at a signature on a Picasso or on a baseball card and confirm that it was indeed signed by the artist himself or that famous baseball player. Now, the problem we have with RFID tags is that although there are tags out there that perform mutual authentication, I've been unable to find any that can do one-way authentication. And the reason is simple. One-way authentication requires asymmetric key cryptography, which is quite computationally expensive. So these little low-power chips with very few logic gates just aren't able to embody the functions required in order to perform digital signing. This gets me back to that throwaway comment I made on Friday about writing up my RFID plus blockchain patent, because what that involves is giving low-cost, low-power RFID tags, such as the MyFair Plus or DesFire, the capacity to, for a limited number of times, do one-way authentication. That is, prove to anybody who wants to ask that the tag is who it says it is. So anyway, that's today's video. It's gone on a bit longer than I wanted, but covered quite a lot of ground, I think. Hope you found that interesting, and tomorrow I'll dig more into this supply chain and blockchain stuff. Hope you're finding it interesting, and see you tomorrow. Bye for now.